In this video, we are talking about x and y intercepts and how to find them from a graph, from an equation, and from a table. We're going to start with looking at graphs and how to find the x and y intercepts. These notes here are just to help you as we go through the process of finding x and y intercepts on a graph. So it's important to know that for x-intercepts, that's the point where the line crosses the y-axis. So the point on the graph is always going to be an x value with a y value of 0. Then for the y-intercept, that's the point where the line crosses the y-axis. So the point will always have 0 for the x value and a y value will be a number. So let's start with looking at how to find x and y intercepts from a graph. So we're going to identify the x and y intercepts and write them as an ordered pair, which is an xy point. Right, and number 1, the x-intercept, or the point where the line crosses the x-axis, is here, and that point is 2, 0. Because we went right 2, up or down 0. Then the y-intercept, remember your y-axis goes up and down. So the line crosses the y-axis at 0, -2, because you went left or right, none, from the origin, and you went down 2. All right, number 2, the x-intercept. So this line crosses the x-axis at 2, 0 again. And the y-intercept is 0, 2. In number 3, the x-intercept is at -1, 0 because we went left 1. And then the y-intercept, it's a little bit hard to tell, but it's down here at the very bottom. And we went left or right, none, down -5. And then number 4, the x-intercept is at -3. So as a point, we went left 3, so -3, 0. And the y-intercept, we went up 2, but we didn't go left or right any. So that's the point 0, 2. All right, now let's look at how to find x and y intercepts from an equation. So there are two forms of linear equations. Slope-intercept form, which is y equals mx plus b, that's what we're pretty familiar with. And in this slope-intercept form, the b is your y-intercept. But your equation could also be written in standard form, which is ax plus by equals c, where a, b, and c are just any numbers. So it doesn't matter which form the line is written in, but in order to find the x-intercept in either form, you're going to plug in 0 for y and then find what x is equal to. So if you want to know x, you're going to plug in 0 for y. Now on the other hand, if you want to know the y-intercept, you're going to plug in 0 for x. All right, so let's look at some examples of equations and finding the x and y intercepts from the equations. Okay, in number 1, we have x plus y equals 8. So let's find the x-intercept first. So to find the x-intercept, we're going to plug in 0 for y. Notice I'm putting it in parentheses. Anytime we plug something into an equation, we want to put it in parentheses. All right, and now if we solve for x plus 0 is just x equals 8. So the x-intercept is 8, but we want to write that as a point. Well, if we were to graph it, the x-intercept being 8 means on the x-axis we go over to 8. And as a point, that would be the point 8, 0. Because x is 8 and y was 0, because we plugged in 0 for y. So y is 0. All right, now let's find the y-intercept. X plus y equals 8, and we want to know the y-intercept. We're going to plug in 0 for x, and then solve for y. So 0 plus y is just y equals 8. So as a point on the y-axis, we're going to go up to 8 and put our point. And that would be the point 0, 8. Because we got that y equals 8 when x is 0. Now let's draw this line. I'm going to draw it just as perfectly as I can. If it's a little bit off, that's okay, but I think that's pretty good. And then we'll draw the arrows on the end. Okay. Now, in example 2, again, we have standard form here, and that's fine. We want to find the x-intercept. So to find the x-intercept of 2x plus 3y equals 12, if I want to know x, plug in 0 for y. So 2x plus 3, and then we're plugging in 0 for y. Now just solve for x. So 3 times 0 is 0, so that's just 2x equals 12. And then divide by 2. So we get x equals 6. Okay, so x is 6, so we go over to 6 and put our point and write it as an ordered pair. So as an ordered pair, that is the point 6, 0. And now let's find the y-intercept of 2x plus 3y equals 12. All right, if I want to know y, plug in 0 for x. And solve for y. So that gives us 2 times 0 is 0. So 3y equals 12. And then divide by 3. So y equals 4. So on the y-axis, we're going to go up to 4. And as a point, that's the point 0, 4. And then draw our line through those 2 points. So notice that we talked about graphing lines in slope-intercept form. You can also graph lines in standard form if you find the x and y intercepts, because in order to draw a line, you just need 2 points. All right, and finally, example number 3. Example 3 is in slope-intercept form. So if we have y equals, I'm going to write this, it's negative 3 over 2x, so negative 3 halves x plus 3. So if I want to know the x-intercept, I want to know x, plug in 0 for y. And solve for x. So here we have to locate that we want x by itself, so we have to move the constant term first by inverse operations. Okay, so 0 minus 3 is negative 3 equals negative 3 over 2 times x. All right, and now we need to undo that fraction. So to undo this fraction, we would have to undo the division first. So we have to do times 2 on both sides. So multiplication by 2 and division by 2 cancels out, and we simplify. So 2 times -3 is -6 equals, and then we have -3 times x. And finally, we can split the -3 away from the x through division. So that gives us -6 over -3 is a +2 equals x. So our x-intercept is +2. Now as a point, that's the point 2, 0. Okay, now my y-intercept is actually a little bit easier. Because this is in standard form, we can actually just look at the b value to find the y-intercept. Okay, so since we had y equals -3 over 2x plus 3, the plus 3 is our b value, which is our y-intercept. So the y-intercept is 3, and that's because if we plugged in 0 for x, notice what would happen. -3/2 times 0 is 0. So we would still get y equals 3. That's only because this was already in slope-intercept form. All right, so y equals 3 for our y-intercept, and then we're going to draw that line. So that is how you find your x and y-intercepts from graphs. And I forgot to write that this y-intercept would be 0, 3. And then let's talk about finding x and y-intercepts from a table. So when you have a table, if you see a 0 somewhere, that indicates that there is an x-intercept or a y-intercept. So remember how if it's kind of like you're thinking about opposites a little bit, because anywhere that there's a 0, that tells you the other intercept. So if y is 0, that's the x-intercept. If x is 0, then that y value is the y-intercept. Okay, so notice that anytime you see a 0, you could circle it and say, well, if y is 0 and x is some number, that's my x-intercept. Or if you have your 0, but x is 0 and y is a number, then that's your y-intercept. So let's do a few examples of those. All right, so anywhere I see a 0 in the table, that's going to give me one of my intercepts. But I have to think about which one it is. So this is the point 0, 6. And if this is an xy point, then when x is 0, y is 6. So that's my y-intercept. Okay, now I have another 0 in the table. But this time, the 2 is my value. So this is the point 2, 0. So as an xy point, my x is 2 when y is 0. So this is my x-intercept. Okay. So the x-intercept is 2, 0. And the y-intercept is 0, 6. All right, let's look at example 2 and find the x-intercept. So find your zeros in the table. So I have a 0 here, and I have a 0 here. All right, well, if I'm looking for my x-intercept, that's when y is 0, so that's the point 6, 0. My y-intercept is when I have a y value and the x is 0. So if x is 0, y is -3 is my y-intercept. Now the next one, example 3, notice we don't have any zeros in the table, but since this is a linear table, what we can do is use the rate of change or the slope to determine where would those zeros be. So let's look at our rate of change. All right, so from -3 to -1, that's going up by +2. And the change in y, from -5 to -3, that's going up by 2. So my rate of change, or my change in y over change in x, is 2 over 2, which is 1. So that tells me what I can do is I can find the in-between values that aren't listed. So we can list out if x is -3, what if x was -2, what would that y value be? So what would be the number between -5 and -3? Right, and then we could continue doing that. So between -1 and 1 would be 0. And from -3, we would go -2, -1. Then from 1 to 3, there would be a 2 between there. And -1 plus 1 would be 0, plus 1 is 1. So all we did here was we had to fill in those extra table values. Since we knew the rate of change, we could do that. So now let's find our zeros. We have 0, -2, and then we have 2, 0. All right, so for the x-intercept, that's when we have an x value and y is 0. So for the x value of 2, that's when y is 0. And for the y-intercept, we have a -2 when x is 0. So 0, -2. Okay, so I just want to remind you that don't get these mixed up looking for your zeros. So wherever you have a 0 in the table, so here we have a 0, the y is -2. So that's our y-intercept. Then when we have the point 2, 0, the 2 is the x value. So that is our x-intercept. So that is how you find x and y intercepts from a graph, from an equation, and from a table.